Hello everyone, welcome back to online class. I am Akkamahadevi from Upper Public School, Kalaburagi. So today I am here with the same chapter, that is work, force and energy. So before starting this class, let us recall what you have learnt in the previous class, okay? So in the previous class, we have learnt about what is force, right? So what do you mean by force? Yes, force is defined as a push or pull that makes an object move, isn't it? So force is a push or a pull which makes an object move. So if the object moves, then only we can say that we have applied a force on it, right? Okay. So even force is also applied to change the shape of an object, isn't it? So as you can see in the picture. So even by applying force, we can also change the shape, isn't it, of an object. Okay. And even force is also said to be applied when an object is twisted, isn't it? Or bent or squeezed. Okay. So even we can say that force is applied when an object is twisted or squeezed or it can be bent, right? So this is all about force, what we have learnt in the previous class. Okay, so after that what we have learned? Exactly, types of forces. Which were there? Yes, frictional force, balanced force, gravitational force, magnetic force, electrostatic force. Okay, so once again I will repeat. Frictional force, balanced force, gravitational force, magnetic force, electrostatic force. Okay, so what do you mean by frictional force? Yes, let me tell you. So frictional force is the force that acts between a moving object and the surface along which it comes. Okay, so what do you mean by frictional force? Frictional force is the force that acts between a moving object and the surface along which it comes. So always where the friction takes place, opposite, isn't it? Yes. So next is balanced force. So what do you mean by balanced force? The equal forces applied in opposite directions are called balanced force. Okay, so where we can see equal force like balanced force. Yes, for example, I have said even in the previous class while playing tug of war and even while playing seesaw, isn't it? So there we balance. If the opposite directions, opposite the those who are, if they are of same, then they can balance, isn't it? So that is called as balanced force. Okay. So next is gravitational force. Okay. So here the force of the earth pulls all objects downwards. Okay, so here what happens? All the objects move downwards, isn't it? So this downwards pull of the earth is called the force of gravity. Okay, so here what happens? All the objects will move downwards. Okay, so if there was no gravitational force, then we all would be flying, isn't it? So because of the gravitational force only we are here, right? So next is magnetic force. So what is this magnetic force? Yes, it is a force exerted by a magnet. So as I said you, like the magnet is a natural source, isn't it? So which attracts all the iron materials, right? So where the iron materials will attract to the magnet? Yes, to the poles of the magnet, that is North Pole and South Pole. Okay, so what happens here? The iron fillings will attract to the poles of the magnet, isn't it? That is a force exerted by a magnet. Okay, this is about magnetic force. Next is electrostatic force. So what do you mean by this electrostatic force? Yes, electrostatic force is the force exerted by a charged body on another charged or uncharged body. So for this I have said you the example, like if we take few pieces of papers and if we take a scale or comb, so just you rub to your head when you applied oil. Okay, so when you rub the scale or comb, so after that you just try to attract, just to keep that comb or scale up near to the small papers where you kept. Okay, so what happened at that time? Small papers will attract to the magnet, isn't it? So there the force is exerted by a charged body on another charged or uncharged body. Okay, this is about electrostatic force. So next, even we have learnt about work, isn't it? So what do you mean by work? Yes, work is said to be done when something is moved through a distance. Okay, force is needed to do work. So when we say that work is done when something is moved through a distance, then only we say that work is done, isn't it? So to do work, what we need? So when we apply a force, then only we can do a work, isn't it? So force is also needed to do work. Okay, this is about work. So next, what we have learned? Yes, energy, isn't it? So what do you mean by energy? So energy can be defined as the ability to do work. Okay, so what do you mean by energy? Energy can be defined as the ability to do work. Okay, so here what happens? Without energy we cannot do anything, right? Yes, so even we have learnt about the forms of energy also, isn't it? Do you remember which are those? Let us recall. So here are the forms of energy. Which are those? Mechanical energy, wind energy, heat energy, solar energy, electrical energy, sound energy, muscular energy, light energy, chemical energy, and magnetic energy. Okay, so let me revise once again. Mechanical energy, wind energy, heat energy, solar energy, electrical energy, sound energy, muscular energy, light energy, chemical energy, and magnetic energy. Okay, so these are the forms of energy. Let us discuss one by one in detail. Okay. So first, mechanical energy. So what do you mean by mechanical energy? Okay, so mechanical energy is the energy that is possessed by an object due to its motion or due to its position. Okay, so mechanical energy is the energy that is possessed by an object due to its motion or due to its position. Okay, so mechanical energy can be either kinetic energy or potential energy. So now you all might be thinking that what is this kinetic energy or potential energy, isn't it? So these are the forms of mechanical energy. Okay, now let us discuss what is this kinetic energy and potential energy. Okay. Yes, so kinetic energy. So here the energy that a moving object has is called kinetic energy. Okay, so what do you mean by kinetic energy? The energy that a moving object has is called kinetic energy. So now what might be the examples for this? Obviously, a moving stone, okay, a moving stone, a moving marble, isn't it? A moving car, a moving bus. So these are the examples of kinetic energy. Okay. So next is potential energy. So what is this potential energy? The energy stored in an object because of its position is called potential energy. So here the stored energy will be called as potential energy, and the examples are a stretched rubber band, okay, water in dams, isn't it? So these are the examples of potential energy. Okay. So here you can see. So this is the position of potential energy. Okay, so when we throw a ball, when it is in motion, the kinetic means motion. So when it will be in motion, it converts it into kinetic energy. So here potential energy is converting it into kinetic energy. So even you can see here potential energy. However, the air is filled in the balloon, isn't it? So when it comes out or when it is moving, so it is potential energy. Okay. So next is wind energy. So what do you mean by wind energy? So it is the energy produced by moving wind. So when wind will be blowing, there the wind energy is produced. So where we use this energy? Exactly, this energy is used in windmills, sailboats, etc. Okay, so it is the energy produced by moving wind. Which energy? Wind energy. Okay, so next is heat energy. So how this heat energy is caused? Let us see. So energy we get by burning any fuel or directly from sun in the daytime is heat energy. So the heat which we get from the sun or by burning any fuel we get heat. So that is called as the heat energy. And what are the examples of this? Heater, LPG gas and various stoves are the examples of heat energy which will produce heat. Okay, this is about heat energy. So next is solar energy. So what is this solar energy? The energy from sun is solar energy. The energy which we get from sun is called solar energy. Okay, it is the ultimate source of energy on earth. So which is the ultimate source? Solar energy. Okay, why? Because we get this energy from sun. So what are the examples? Sun's heat or sunlight are the examples of solar energy. Okay, this is about solar energy. So next we will move forward and we will discuss about electrical energy. Okay, so what do you mean by electrical energy? So here all electrical appliances using electrical energy. Okay, so here the like we use many things in our day-to-day life, isn't it? So that is produced from electrical energy. Which are those? Like we use electrical heaters, we use fridge, we use fans, washing machines, isn't it? So these are all the electrical appliances which we are using through electrical energy. Okay, this is about electrical energy. So next energy is sound energy. Okay, so it is also a form of energy. Sound energy, it is also a form of energy. So here what happens? Big sounds have more energy and smaller sounds have less energy. Okay, so here what happens? The big sounds have, the sound will be more, no? So that big sounds will be having more energy and the smaller sounds will be having less energy. And what might be the examples for this? Yes, musical instruments, stereo systems, factories. So these are all which produce sound, isn't it? So this is of sound energy. Okay. So next is muscular energy. So what is this muscular energy? The energy of our muscles to do work is known as muscular energy. So here we are using our muscles to do work, isn't it? So that energy is called muscular energy. And the examples are walking, running, cycling, isn't it? So these are the examples of muscular energy. Okay. So now next is light energy. So here this is the energy emitted by sun, bulbs, tube lights, candle light, etc. Okay, so here this energy is emitted by either a natural source or artificial source. Either it might be a sun, bulbs, tube lights, candle light, etc. So which emits light is called light energy. Okay, this is about light energy. So next is chemical energy. So what do you mean by this chemical energy? So here energy produced by the chemicals is called chemical energy. So here what happens? The energy like chemicals will be converted. So the energy produced by the chemicals is known as chemical energy, right? So here where we use this chemical energy? LPG stove, torch cells, isn't it? And even diesel, car batteries, etc. So these are the chemical energy. Okay. So later on it may convert it into another energy also. So next is magnetic energy. So here energy produced by magnet is called magnetic energy. So as I said you before, like what do you mean by magnet, isn't it? So here what happens, energy which is produced by magnet is called magnetic energy. So which are the examples? Earphones, we use magnets, right, in the earphones, TVs, even in many toys also we can see a small pieces of magnets, isn't it? So these are the examples of magnetic energy. Okay, so we have learned all the forms of energy, right? So now next is biogas. So what do you mean by this biogas? Okay, so as we all know that in many rural areas, villagers are using biogas, isn't it? So in many rural areas we saw like using biogas, which is another type of renewable energy, isn't it? So it is a renewable energy, right? So biogas or gobar gas contains methane. So what it contains? It contains methane, right? So what happens? So how we collect? So it is used as where we use? It is used as a household fuel for cooking, right? So it is an economical fuel as it is obtained from where it is obtained? It is obtained from animal excrete and agricultural waste, plant material, and even green waste or food waste. Okay, so we use all these waste to, yes, to make a biogas, right? So these are the renewable, which we can convert it into a renewable energy, right? This is about biogas. So next is light. So here light is a form of energy which helps us to see everything around us. So when light falls on an object, then only we can see the things, isn't it? So light is a form of energy, and even light helps us to see everything around us. Okay. So here sun and stars are the natural sources of light in the universe. So here you can see the sun and stars. So these are the natural sources of light. And now let us see which are the artificial sources of light, that is man-made. So here candle, torch, bulb. So these are the artificial sources of light which are man-made. These are all not natural source of light. These are artificial source of light. Okay. So next is luminous object. So what do you mean by luminous object? Objects which have light of their own are called luminous objects. So here the objects which produce light of its own is called luminous object. So here a glowing bulb, candle, a torch are luminous objects. So here you can see a bulb will give light, isn't it? We can see. And even bulb also it produce light, and even torch also produce light. So these are called as luminous object. Okay, and even sun is also a luminous object. So next is non-luminous object. So what do you mean by non-luminous objects? objects which do not have light of their own are called non-luminous objects. So here non-luminous objects means which will not produce light of its own are called non-luminous objects. Examples: a tree. A tree can produce light? No. A human body can produce light? No. Book, desk. So many more are the examples of non-luminous objects. And even moon is also a non-luminous object. It will not produce light of its own, isn't it? So moon is also called as a luminous object. So now we will see the objects are of three types. Okay, they are transparent objects, translucent objects, and opaque objects. So what do you mean by transparent objects? So here transparent objects means which allow light to pass through them. So whatever the object is there which will allow the light to pass through them are called as transparent objects. And in the translucent, which will allow the light to pass through but not all, like partially it will allow the light to pass through the object. So that is called as translucent objects. And next is opaque. So here it will not allow the light to pass through, it is called as opaque objects. Okay, so transparent means which will allow the light to pass through, translucent means it will allow partially, and opaque means which will not allow the light to pass through the objects is called an opaque objects. Okay, so here you can see transparent. Okay, so here where all the lights are passes through, right? So in the transparent, all the lights will passes through, whereas in the translucent, you can see here partially, like all the rays are not passing, only few can pass through. And in the opaque, we cannot see any light passes through, isn't it? So this is transparent, translucent, and opaque. Okay, so here you can see the examples. So transparent, glass, even air is also a transparent, and even water is also a transparent. And what about translucent? You can see a fluorescent glass which is a translucent. We can see behind the glass, but exactly we cannot say that, isn't it? And even butter paper is also an example of translucent. And about opaque, wood, isn't it? Even steel, right? So here in the wooden box, if we keep something and if we want to see from outside, can we see? No, it is not possible. So that it is called as opaque. Whereas in the glass, we can see clearly because the light has passed through it. But in the opaque, it will not. Okay. So next is sun and shadows. So as you all know that, yes, sun gives us light and heat, isn't it? So it gives a heat energy and also light energy. Okay, so this energy is known as solar energy, isn't it? So as I said you, like sun is also a luminous object, isn't it? Okay, so see here, you in the image you can see. So here is the sun. So now we will move forward and we will discuss about shadow. Okay, so how these shadows are formed. Okay, so an area of darkness formed by an opaque object obstructing light is called a shadow. So when light falls on an opaque object, so instead of passing the light, the shadow will be formed. Okay, so how the shadows are formed? When light falls on an opaque object, the shadows are formed. Okay, so the nature and size of the shadows depend on two factors, that is the size of the object and source of light, and the distance between the object and the source of light. Okay, so here you can see it is in the morning. Here you can see in the noon and evening. Whether all the shadows are in the same direction? No, always the shadows are formed opposite to the light. So here as you all can see, sun, light. Okay, so the shadow will be opposite to the light. here you can see the shadows, okay, and even you can see here also. So when the light will be in the middle, so see here the shadows will be very small, okay. So always the shadows are formed opposite to the light, okay. So now next, so here you can see the length of the shadow always depends on the position, okay. It will depends on the position of the sun during the day, okay. Observe your shadow here, okay. On a bright sunny day, at different times in the morning and evening, your shadows will be longer and sun is very low, but in the midday your shadows will be shortest as the sun is high, okay. So the region of complete shadow is called the umbra, okay. So what do you mean by this umbra? The region of complete shadow is called the umbra and the region of diffuse shadow is called the penumbra, okay. So once again I'll repeat this. The region of complete shadow is called the umbra and the region of diffuse shadow is called the penumbra, okay. So these shadows are formed on the earth during a solar eclipse, okay, and from the umbra we can see a total eclipse, while from the penumbra only a partial eclipse is visible, okay. So this is about the umbra and the penumbra, okay. So now here are few shadows, okay. So just by seeing the objects, can we match these objects with the shadows? Okay, so here you can see a dog. So can we identify the shadow of the dog? Exactly, we can identify the shadow of the dog, and even here duck. We can identify by seeing the shadow of that object, okay. So here also dog we can identify, and even doll also we can identify. And what about this? So here is the shape of square, okay. So the shadow will be same, like we can identify the shadow of the square, and even circle, and here hexagon, and here heart, and here star, and here is triangle. So can we identify the shadows by without seeing the objects, whether we get the accurate shadow? Not always. Sometimes we can identify the shadows without seeing the objects, but not every time, isn't it? So this is all about force, work and energy, okay. Hope you all enjoyed this class. Thank you.